Hello and welcome to section 1.4. This is all about the transformations of graphs and all the things that can happen to it. And so I thought we'd start with this table. You guys need to get this down, and I'll just kind of talk you through them as we go. This first one right here is a vertical translation up k units, so the key is the k value here, and so we have some function, we're adding a value to it, so then and if k is greater than 0, then we're shifting it up. If we want to shift the function down, it will be written basically the same. It'll be written as y equals f of x plus k, but this time it'll be where k is less than 0. So that makes it shift down so many units. And you guys have seen this before, especially like when you deal with functions like this one would be something like f of x equals x squared plus 2, and this one might be like f of x squared minus 3 or something like that, that's shifting it up and down. So that's what we're talking about here. And then this one we have a horizontal translation to the right, and so when we have a negative, it's the opposite direction of what it looks like in the function. So in this case it might be something like y equals x minus 2 squared, and that would shift it to the right 2 units. And down here we'll have a horizontal translation that shifts it to the left of h units left. And so what does that mean for our function? Well, that would be something like y equals x plus 2 squared. And so that would shift it to the left in this case. And so that if we put a value of a and we multiply some function by a, this is where we get a vertical stretch by a factor of a. And this is the same as saying like y equals 3x squared. This would make the graph much narrower than the original x squared. Where down here, where we have a vertical compression, where a is between 0 and 1, if it was y equals 1/3 x squared, then the graph would be a lot lower and wider. So that's compression. It's getting pressed down towards the x-axis. This one is getting pulled up away from the x-axis. Now these next two are ones that we don't use very often, but we need to kind of talk about them. They do happen. Where these come up is basically in our trig functions when we start talking about different things. And so when we put a b value here in front of the function, inside the function, where we're talking about something like, I don't know, the function might be like y equals 3x squared or something like that. Well, that'd be 1/3 x squared because it's got to be between 0 and 1. We get a horizontal compression. So the graph will get pushed together, and it'll look I don't know, it'll look a lot narrower and stuff. And then when b is greater than 1, we get a horizontal stretch. And in this case, we'll talk more about these, and that would be something like 5x squared. But we'll talk more about these when we deal with trig. That's where these pop up the most. And then a common one is a reflection across the x-axis, and that would be something like y equals negative f of x, or y equals something like negative x squared. It's the parabola but flipped over. And then a reflection across the y-axis would be the last one. And so that's what happens with this one. So just so you know, that's what we're talking about. These, you guys have seen most of these before, but please make sure you get these down, so we can talk about them more in class. Alright, so then we want a quick sketch of these. These are just the parent functions that we're trying to get a sketch of. A constant function, well, just to get a graph of this, I'm going to say c equals 3. And so a constant function would be a horizontal line that would look at 3 would be something like that. That's a constant function. That's a parent function of a constant. If it was y equals x, which is what we have there, we get a graph that looks like that. And so then the absolute value function, remember the absolute value function is a piecewise function, is another name for a piecewise function that we could get the graph of. Basically f of x is negative x when x is less than 0, and x when x is greater than or equal to 0, and that's basically what the absolute value function graphs as. And so we could graph it as, okay, for negative till 0 we have a negative slope, and then from 0 on we get our positive slope. And so that's our absolute value of x, or you could just plug in values to get these. Our square root function, if you don't know, I might go ahead and set up a table. And remember, with the square root function, you don't have any negative numbers, so I'm going to use perfect squares here, 0, 1, 4, and 9 to get numbers. If I put 0 in, I get 0, 1 in is 1, square root of 4 is 2, square root of 9 is 3, and so then I could get a pretty decent graph of what this thing's going to look like. And so it will be a nice little curve like that, which will give me a pretty good sketch of the square root function. The quadratic function we have seen quite a bit, hopefully, at this point in time, and so, but if you don't remember, you could always set up a little table to get a table of values. I'm going to go with -2, -1, 0, 1, and 2 to get a decent look at what's happening. If I square -2, I get 4, square -1, 1, 0, 1, and 4. So at -2, I'm up 4. And so then my graph looks a little bit like this. And I could even go over 3 to 9, I know that, and there we go, back to 3. And so my graph, oops, I missed it a little bit, but looks something like that. And so those are our parent functions. There's a parabola, it should be a U-shaped graph. And then finally our cubic function. Again, I'll probably set up a table because I don't know exactly what this is going to look like, but -2, -1, 0, 1, and 2 are probably a good set of numbers. -2 squared is 8, -8, -1 squared is -1. I get 0, 1, and 8 when I plug those into my squares. So at -2, I'm at -8. At -1, I'm at -1, 0, 0, 1, and then 2 is 8. So you can see it's kind of an S-shaped graph that does something like that. And so there is our so those are our parent functions, and that's what everything is based off of. So as we go through these, you'll be looking for things that look like this, and then the changes to them from that table that you just copied down. And then finally, we want to compare these guys to the x cubed graph right here. So there's my x cubed graph is going to be my original graph, so I'll do that one in red, and we just kind of make these graphs a little bit bigger. They seem a little small. So so we can kind of see what's going on here. So on all of these, first thing I'm going to do is I'm going to graph the cubic function since we're used to it. So this is f of x equals x cubed, and so remember we just did this -2, -1, 0, 1, and 2, which gave me -8, -1, 0, 1, and 8. So plugging in those, I'm going to get on all of them, I'm going to get my parent function first. See how good if I can hit these actual points, but close enough. And over here, same deal, because we're going to compare them to the original graph. And so this guy I don't like, I'm going to move him down a little bit. There we go, that's a little bit better. And then the last one, same one. So now that I have all the parent functions here, we should be able to see what happens when we change it, when we do our transformations on them. Alright, so all the transformations will be done in blue to get a different one. And so now if I was to set up a little table x cubed minus 1. Hopefully you can see that all of my values in my y column over here will be moved down 1 unit. And so if I had negative 2, negative 1, 0, 1, and 2, I'll have negative 9, negative 2, negative 1, 0, and 7. So you can see by plugging them in, if I put negative 2 in, I get negative 8. Negative 8 minus 1 is negative 9. Negative 1 squared is negative 1. Minus 1 is negative 2, and so on. So you can kind of see what's happening with that graph. So at negative 2, I'm really at negative 9. At negative 1, I'm at negative 2. At 0, I'm at negative 1. And then here, and right like that. So you can see this blue graph is going to be very similar. It's just down 1 unit. And you probably knew that because of this. My horizontal translation is that it's down 1 unit. So the blue graph itself is the same as the other one, if I could have drawn it the same, but it is pushed down 1 unit from the other one. Alright, so now what's going to happen when we're in here? You probably already know that this is a horizontal translation, and since it's negative 1, we're going to be moving it to the right, so we should find out that we're moving right 1 unit. And so when we do our table here, we have x, y, we have negative 2, negative 1, 0, 1, and 2, and plugging those guys into this function, negative 2 gives me actually negative 3 squared, or negative 3 cubed, which would be, I believe, 27, negative 27. Negative 1 turns into negative 2, which is negative 8. 0 turns into negative 1, which is negative 1. And then 1 will turn into 0, so I get 0. 2 will turn into 1, and I'm going to go to 3. 3 will turn into positive 8. So I'm basically going to ignore this negative 2 and 27 because negative 27 because I can't fit that on my graph. So I'm going to start at negative 1, and this time I'm going to go down 8, right there. And at 0, I'm at at 0 I'm at negative 1, so right there. At 1, I'm at 0, and at 2, I'm at 1. So you can kind of see this is very similar to the previous one. It's just it's pushed over instead of pushed down. And then at 3, I'm at positive 8. So you can see this is the exact same graph, but parallel to it because it is just pushed 1 unit to the right. And that's what we know because our change function, our h value, is inside the parentheses, which means when it's inside you're moving it left and right. When it's outside, like the first one, you're moving it up and down. And so now this last one, we're going to be moving it left and right and up and down. So to get a quick sketch of this, I should know that this graph right here is up 1 unit and basically to the left 2 units. Now I could go ahead and make a table like that, but I'm actually going to just move it because that's how I know. I'm going to copy this. There it is. I'm going to change its color to blue. Alright, so now I have basically this graph. Here we go, same graph. I move it up 1 unit because of the plus 1, and I move it to the right, the left 2 units, 1, 2, which basically there it is. And so that's the same function, that's this function here, up 1 unit and to the left 2 units. And that's basically what the transformations tell us. So we don't have to make the table every time. I'm just trying to show you different ways to kind of look at this. So this concludes the video notes for today. If you have any questions, please come to class prepared to ask them. Thank you.